Hello, math friends. Welcome back to A Squared Math and Stuff. And we are looking at example number 2 for our introduction to limits using a table. In this example here, we have a rational function. So we have equations in the numerator and denominator, and I have left our x values blank. So we need to come up with these x values, and then we need to use our calculator to calculate the y values and figure out what the limit is as x approaches -1 in this case. So I'm going to write -1 in the middle here. Now I need to figure out what we need to put in the left-hand side and the right-hand side values. You'll recall that I talked about adding and subtracting a tenth, a hundredth, and a thousandth. So let's go ahead and let's write a number line here. Let's do a number line. And I'm going to put -1 in the middle. So I need to add a tenth to the right, and I need to subtract a tenth on the left. So if I add a tenth to a -1, so -1 plus 0.1, we end up with a -0.9. If I subtract 0.1 from a -1, I end up with -1.01. So now I need to subtract and add a hundredth. So I'll add a hundredth and I will subtract 100th. And that will take me to a negative, wait a minute, I wrote this wrong. This should be -1.1. I'm sorry, let me just cross this off. -1.1. All right, let's get back to this. All right, so this would be a -1.01 and then a -9.99. And then finally, we have to subtract a thousandth and add a thousandth. So we're continuously getting closer and closer and closer to this middle value, or what we're looking to approach, of -1. So subtract a thousandth and add a thousandth. And we will have our values of -1.001 and -0.999. So these numbers here are the numbers that we want to put in our table. So filling in -1.1, -1.01, -1.001, and then on the right-hand side, we have a -0.999, -0.99, and a -0.9. In our last example, we had a linear equation that we were looking at taking the limit of. So this time I want to plug in the -1 like I did with my previous example and see what happens. If we plug in a -1, -1 plus 1 all over -1 squared minus -1 minus 2, we end up with 0 over 0. We don't know how to calculate 0 over 0. In our world, this doesn't exist right now. And if we take a look at this, because it is a rational function, we can actually factor our denominator. So let's look at that. If we factor the denominator, we have x plus 1 in the numerator, and we'll have x minus 2 times x plus 1. And then we can cancel these. If we cancel these, that means we have a hole. So if we have a hole in our graph, we cannot have a y value at that spot. So -1, we cannot have a value because we have a hole at x equals -1. But because there's a hole doesn't mean that we can't take some curve and follow it and get really, 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 really close to an x value of -1. So let's figure out what that value is by getting really, 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 really close. Well, let's see here. First, let me show you what I mean, because I did print out the graph for this equation. So this is the equation we're looking at. We're looking at our limit going to -1. Negative 1 is right here. Coming in from the left-hand side, your left-hand side is the more negative side. Your right-hand side is the more positive side. So as we come in and we follow these curves from the left and from the right, we're wondering if we're going to meet in the same spot or near that same spot, but along the same line. So in this case, as we get closer and closer to negative 1, these lines pretty much, you can say this is a continuous line, except we know there's a hole there. So we should have a limit here. So let's take a look at this table. Let's see what our limit approach is here. So again, get out your calculator. We're going to type in this equation. If you have anything in your y equals, go ahead and clear it out. And I'm going to show you how to enter a fraction in here. So what I want you to do, a fraction in terms of numerator and denominator, if you don't know how to do it, you'll hit the alpha key, and then you're going to hit y equals. And this first selection here, n over d, stands for numerator and denominator. So if we hit enter on that, you'll see that we actually get a position to enter our numerator of x plus 1, and then we get a position to enter our denominator of x squared minus x minus 2. This helps us out because sometimes we forget to put parentheses in and we screw everything up, so we don't really need to worry about the parentheses with this. So numerator is x plus 1. I arrow down to get to my denominator. I then have x squared minus x minus 2. So you can see I have everything in the correct position. And now, again, if you don't have your table set to ask, do second window and make sure that your independent variable or your x variable is set to ask so that we can tell it exactly what numbers we want to look at. So now go into table, so second, graph, and if you have numbers in here, we are just going to make sure you highlight your top number and then just keep hitting delete, and we can clear this all out. Now I'm just going to start plugging in these x values. I'm going to plug in a negative 1.1. I get a negative 0.3226. Negative 0.3226. And then a negative 1.01 is our next x value. Our y value is negative 0.3322. Negative 1.001. We get negative 0.3332. If you want to try, you can plug in a negative 1, and you'll see we get an error. So we don't actually have a number, and that makes sense because we calculated that there's a hole at negative 1. So that's our question mark. I know you can't see that screen very well, but let's plug in the negative 0.999. We get a negative 0.3334, plugging in negative 0.99, negative 0.3344, and last one, negative 0.9. We get negative 0.3448. So does the limit exist? The answer is either yes or no. On the left-hand side and the right-hand side, are these two numbers getting really close to the exact same y value? Because this is f of x, our function, or a y value. These both look like they're getting really, really, really close to negative 0.3 repeating. And negative 0.3 repeating is the same thing as 1/3. So our limit as x approaches negative 1 of x plus 1 all over x squared minus x minus 2 is equal to 1/3, or, sorry, negative 1/3, negative 0.3 repeating. And again, let's take a look at the graph that I printed. When we go to negative 1, we should have what looks like a hole at negative 1/3 for the y value. And the graph that I got online didn't have the hole there, but if we go to negative 1, it looks like we go about negative 1/3 down, And this is where we would have our hole. So we did it right. If you like what you saw, click that subscribe button down below, and I'll be chatting with you later.